Welcome back. We're now on section 2.2, so we're going to look at analyzing conditional statements. So a statement is a sentence that is either true or false. That is called the truth value. So it's represented by letters P or Q. So supplementary angles have a sum of 180 degrees. So the truth value is going to be considered T. So because that is a true statement, supplementary angles do have a sum of 180. There's also going to be negation of statements. So a negation of a statement has the opposite truth value. So it's shown by the symbol not P. So that little squiggly line means not. Sorry, and let me zoom in for you guys. So for example, we have not P, supplementary angles do not have a sum of 180. So the truth value of that is false because they do have a sum of 180. And it's the opposite truth value of statement P, which was supplementary angles have a sum of 180. There's also compound statements. So that's two or more statements joined by the words and or. I'm going to put those in quotation marks since we have a double or there. A conjunction is when the statement is joined by the word and. And it's going to be written as P and Q, which is this like upside down caret symbol. And that is going to be true when both statements are true. A disjunction is going to be when they are joined by the word or. And for that one, it's written as P or Q. So it's like a V shape. So that is going to be true when at least one of the statements are true. Okay, so a little bit of practice with this. So they're going to give you some different statements. So they give you that P is there are 7 days in a week. So just to make a little side note for us, we're just going to write down that is true. March has 30 days. That's false. There's 31. And then Halloween is on October 31st. That is true. So then they're going to ask us to go ahead and combine some of these statements. So the first one they ask for here is P and Q. So I'm going to take statement P, put in an and then take statement Q. So there are 7 days in a week. And so where I got that from is up here. So I know the statement goes with and. March has 30 days. So when deciding the truth value on that, it has to be both statements are true in order for this to be true. So because March does not have 30 days, this is false. So the next one is Q and R. So that would be March has 30 days. And Halloween, so I'm missing an L there. Halloween is on October 31st. So again, both statements would have to be true because this is an and statement, so that is false. Okay, another example. Let's move on to an or statement. So I'll let you try number 3 on your own. Let's try some different statements. I'll let you try 3 and 4 on your own, and we're going to move on to some or statements. So number 5 is P or R. So we want to take statement P. So there are 7 days in a week. Or statement R, which is Halloween, is on October 31st. I'm just going to abbreviate the date there. So in order for an or statement to be true, at least one of the statements has to be true. In this case, they're both true. So it's true. Let's do another or. So we'll do number 6. So not Q or R. So Q is March has 30 days, but we want the opposite of that. So March does not have 30 days. Or, and then just regular R. So or Halloween is 10-31. So in order for this to be true, since it's an or statement, just one of these two statements has to be true. They're actually both true in this case. Let's also do number 7. So number 7 is not P or not R. So not P, there are not 7 days in a week. Or R is Halloween. And because it's negated, is not on 10-31. So in order for this to be true, one of these would have to be true, one or both. In this case, neither of those statements are true, so this is false. So I'll let you try number 4 and number 8 there on your own, and you can check your answers. You can also practice writing your own statement if you would like. That's up to you if you want to do that much practice. But we're going to go ahead and move on to the next page. Okay, next page is conditional statements. So a conditional statement is a statement that can be written in if-then form. So symbolic form is going to look like P arrow Q. So it's going to be read as P implies Q, or if P, then Q. The hypothesis is the phrase immediately following the word if. And then the conclusion is the word immediately following then. So identify the hypothesis and the conclusion of the following statements. If you live in Nashville, then you live in Tennessee. So the hypothesis is you live in Nashville. The conclusion would be you live in Tennessee. I'm just going to abbreviate. Another example, if the sum of the measures of two angles equals 90, then they are complementary. So sum measures two angles equals 90, then they are complementary. Okay, I'll let you try 3 on your own. The next part of this is practicing writing statements in if-then form. So we have an obtuse angle has a measure greater than 90. So I could say if an angle is obtuse, then its measure is greater than, oops, that's a greater than sign, greater than 90. So next up is all numbers divisible by 4 are also divisible by 2. So we could say if a number is divisible by 4, then it is divisible by 2. Okay, so I'll let you try those other statements on your own and being able to convert them into if-then statements. So moving on to this side here. So a couple more definitions. So there's also going to be an inverse. So this is formed by negating the hypothesis and the conclusion. So negating. So it's going to look like not P, then not Q. The converse is formed by switching the hypothesis and conclusion. So that's going to look like Q. So if Q, then P. Oops, I'm sorry, I just did if Q, then Q. There you go. And then the contrapositive is formed by negating and switching the hypothesis and conclusion. So that's going to be not Q, then not P. So an example here. So if it is Saturday, then there is no school. So for the inverse, if you look back at that, you're just negating the hypothesis and conclusion. You're not changing the order. So it would be if it is not Saturday, then, so instead of there is school, since we have to do the opposite, there is no school. The opposite of that is there is school. So then there is school. That's a confusing one. We have a double negative. So then we have to think about, is that true? So in most cases, yes, if it's not Saturday, there is school, but what if it's Sunday? So it has to be false because it could be Sunday. Okay, so the converse is formed by switching the hypothesis and the conclusion. So you do not negate anything. So we're just going to flip the order around. So we're going to say if there is no school, then it is Saturday. I'll just abbreviate Saturday. So again, Sunday is an exception to that. It could also be Sunday. So that's false because of Sunday. And then the contrapositive, we flip the statements and negate them. So it's going to be if there is school, since we want the opposite, then it is not Saturday. Okay, so think about that one. I'll just abbreviate there. So if there is school, then it is not Saturday. That is a true statement. Okay, I'll let you attempt 2 or 3 on your own and then check your answers. Just pick one of those to try on your own. And then we're going to go ahead and continue on to the next part. Okay, so then that takes us to biconditional statements. So a biconditional statement is the conjunction of a conditional and its converse. So conjunction of conditional and converse. So what that means, so conditional is just regular if P then Q, converse is if Q then P. So basically you can go either direction. So that's going to be read as, on that one, it's going to be P, and then it's going to be an arrow going both directions because both of those are true. So it looks like that, and it's read as P if and only if Q. So biconditional statements are going to be true when both the conditional and converse are true. Sorry, I meant to do a capital H there. Both conditional and converse are true. Okay, so an example here, if two angles are supplementary if and only if the sum of their measures is 180 degrees. So they want us to write out the conditional statement, so that's the just regular if P then Q. So I would say if two angles are supplementary, then the sum of their measures is 180. Converse, so that's going to be the reverse of that. So if the sum of two angle measures is 180, then they are supplementary. So then to determine if they're true, remember that both of these statements have to be true. So if two angles are supplementary, the sum of their measures is 180, that is true. If the sum of two angles is 180, then they are supplementary. That's also true. So this would be considered a true statement. Okay, so I'll let you try one of the other ones on your own, and then you can check your answers in the answer key. So we're going to continue on. So this is Mind Your P's and Q's, a graphic organizer for logic statements. So this is just going to help us to review all the different things that we've covered. It's a good summary. So the conjunction, remember, is when you have P and Q. Disjunction is P or Q. So if we're looking at these two statements here, so P is vertical angles are congruent, Q is 15 as a prime number. So I would say vertical angles are congruent and 15 is a prime number. And I'm going to use the congruent symbol. Okay, so in order for that to be true, both those statements have to be true. So vertical angles are congruent, that's true, but 15 is not prime. 15 can be broken into 3 and 5. So remember, to be prime, it just has to be able to be multiplied by 1 in itself. So that's false. The disjunction is where you use or. So I would say vertical angles are congruent, or 15 is prime. So in order for an or statement to be true, just one of the two statements has to be true. So because vertical angles are congruent is true, the whole statement is true since it's an or statement. And then just to review our conditional statements here. So the conditional is just your regular if P then Q. So in this case, our P is it is St. Patrick's Day and our Q is it is March. So our regular statement would be if it is St. Patrick's Day, then it is March. So that is true. The inverse is where you negate both statements. So not P, not Q. So if it is not St. Patrick's Day, then it is not March. So that statement, let's see, so if it is not St. Patrick's Day, then it is not March. So not St. Patrick's Day means that it is not March. So that is going to be true. Or I'm sorry, what am I thinking? That's false. Because it could be any of the other days in March, sorry. So it could be March 1st, March 2nd, March 3rd, March 4th. So that is false. All right, continuing on, converse is going to be if Q, then P, so you flip the order. So that is if it is March, then it is St. Patrick's Day. So that is false because it could be any other day of March. So just like the one above, it could be March 1st, it could be March 30th. Contrapositive is when you negate and you flip the order, so it's not Q, not P. So this would be if it is not March, then it is not St. Patrick's Day. Just going to abbreviate on that, and that is true. Biconditional statement, so that's when you have the double arrow, and it's the if and only if. So this is, it is St. Patrick's Day. If and only if it is March. Okay, so on this one, I'm going to go back for a second to where we talked about those biconditional statements. So in order for that to be true, both the conditional and the converse have to be true. So we need to check. So our conditional is true. Our converse was false though. So that means that this has to be false. So those require a little bit of thinking to figure out if they're true or false. Okay, and that's it for section 2.2. Thanks for watching. We'll see you next time.